Welcome to section 4.1, greatest common factor, also known as GCF. Go ahead and press pause and write down the information. Okay, so we're talking about common factors and greatest common factors. So a common factor are factors that are shared by two or more numbers. Okay, now first of all, we have to understand what a factor is. So a factor are the numbers that multiply together to give you a specific product. So for example, if I look over at my factors of 8 and 6, 1 times 8 is 8, 2 times 4 is 8. Those are the only four factors of 8. For 6, I have 1 times 6 is 6, and 2 times 3 is 6. These are my only factors of 6. The common factors that they share are both 1 and 2. So if I were to list my common factors, I would list everything they have in common. Now your greatest common factor is the largest factor of two or more numbers. So once again, if I'm looking at the factors of 8 and 6, my largest common factor is the 2. So 2 would be the GCF, the greatest common factor of 6 and 8. Okay, so common factors are all numbers they have in common. Greatest common factors is the greatest number they have in common. So greatest common factor can only have one number as its solution. Now there are two different ways to find greatest common factor, and it's really up to you to choose the way that you prefer. I will always prefer prime factorization method because I feel it's a little bit harder to forget numbers that way. So if you look at how to find the prime factorization of 8 and 12, if you list the factors, what you have to do is make sure you list every single possible factor. Okay, so if it's for a number like 150, you have to make sure that you have all the factors of 150. So if you're not sure if you know all those factors, then using prime factorization is going to be a better method. But for numbers like 8 and 12, we know all the factors of 8, we know all the factors of 12, and the greatest common factor is 4. Okay, so when I list out the factors, I'm just finding the GCF, the greatest common. So not all common, which would be 1, 2, and 4, the greatest common. For prime factorization, you're going to do the factor trees for both 8 and 12. And the factors for 8 are 2 times 2 times 2. So look over here, 2 times 2 times 2. For 12, I have 2 times 2 times 3. And you're going to make sure, because it's a multiplication problem, that you include all numbers that they have in common. Okay, and the reason we include all numbers they have in common is because it's multiplication. Okay, so they actually both have a 4 in common. 2 times 2 is 4. And that's how I get my answer. So what you'll see me do today is a lot more of the prime factorization method on your own. If you want to press pause and do it using the listing the factors method, you're more than welcome to do that. And then just compare our answers. So we're going to find the prime factorization of 18 and 30. So I'm going to go ahead and do my tree diagrams for 18 and 30. So for 18, I have 3 times 6. 3 is prime. For 6, I have 2 times 3, and 2 and 3 are prime. For 30, I have 3 times 10, and 3 is prime. For 10, I have 2 times 5. Okay, so I like to list my factors, and I always will put the 18 and then list all my factors for those, my prime factors. And for the 30, I have 2 times 3 times 5. And you notice how I always put them in numerical order, so it's easier for me to see. Okay, keep my 2's together, my 3's together. Okay, now I'm circling all numbers they have in common. So they have a 2 and a set of 3's in common. So I'm going to take 2 times 3, which is 6. So my greatest common factor, your GCF, is 6. Okay? The 3 and the 5 are not part of this problem in this case because they are not common factors, and we're circling all the common prime factors for those. Okay, we're going to do the same thing. Once again, I'm going to use my tree diagrams. If you want to use another method, go for it. Okay. Remember to break these down. 6 times 10 is 60. 6 is composite, so I break that down to 2 times 3. For 10, I have 2 times 5, and then these are all my prime numbers. So for 60, I have 2 times 2 times 3 times 5. For 54, I have 6 and 9. Both of those are composite. So I have 3 times 2, and then 3 times 3. So for 54, I have 2 times 3 times 3 times 3. Okay, all my common numbers. Once again, I have a 2 and a 3. Notice how I'm not circling this way. It has to be common between both numbers 60 and 54. So once again, I have 2 times 3, which is 6. So the greatest common factor is 6. Okay, and our last one, 32 and 48. So I have 8 times 4, which can break down to 4 times 2, and then 2 times 2. I have a lot of 2's here. Once again, circling it just helps you keep everything organized. And then I have my 2 times 2. Okay, for 48, I'm going to do 2 and 24. And then 2 and 12. Then it's 6 and 2. And then 3 and 2. So for 32, I have 2 times 2, oops, times 2, times 2 times 2 times 2. Right, got all my 2's there, 5 of them. For 48, I have 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4 2's, 1 3. Okay. So what I have in common, I have a 2, a 2, a 2, a 2. So I have 2 times 2 times 2 times 2, and make sure you're multiplying, not doing 2, 4, 6, 8. So 2 times 2 is 4. 4 times 4 is 16. So the greatest common factor, oops, is 16. Okay? So once again, when using prime factorization, you're going to find all the prime factors they have in common, and you're going to multiply them. When I'm listing the factors, I'm just going to list out the factors and just find the largest one. Okay, so that's the difference. I would use these for the bigger numbers you're not so sure about, and then you can list the factors for the smaller ones that you know for sure you know all the factors of. Okay? All right, thanks for watching. We'll see you tomorrow.